breaking the barrier. Scientists successfully transport antimatter by truck in a landmark achievement for particle physics. Researchers have successfully transported antimatter via truck for the first time. This milestone, achieved during a controlled journey around the CERN campus in Geneva, proves that one of the most volatile and fragile substances in the universe can be moved without being destroyed. The challenge of antimatter is the mirror image of ordinary matter. While they share many properties, they have opposite charges. The fundamental problem is that when matter and antimatter meet, they annihilate each other instantly, releasing a burst of pure energy. To study antimatter, scientists must keep it trapped in a state of permanent isolation. This requires a near-perfect vacuum to prevent contact with air molecules, precise electric and magnetic fields to suspend the particles so they never touch the walls of their container. Maintaining these delicate conditions is difficult enough in a stationary laboratory. Doing so inside a moving vehicle subject to road vibrations and bumps was previously considered a massive technical hurdle. The experiment, a 5-mile test drive to prove the concept, a team from the base baryon antibaryon symmetry experiment, collaboration led by spokesperson Stefan Ulmer, conducted a rigorous test. The payload. Scientists loaded 92 antiprotons into a specialized, portable magnetic trap. The journey. The team drove the trap approximately 5 miles 8 kilometers around the CERN campus. The result, despite the motion of the vehicle, the antiprotons remained stable and suspended, successfully avoiding annihilation throughout the trip. This opens, in principle, an entire new universe for precision measurements outside of CERN, noted Stefan Ulmer. Why this matters? Solving a cosmic mystery, this breakthrough is not just a feat of engineering. It is a vital step toward answering one of the biggest questions in science. Why does the universe exist? According to the Big Bang Theory, equal amounts of matter and antimatter should have been created at the dawn of time. If they had been perfectly balanced, they would have annihilated one another, leaving a universe filled with nothing but light. Instead, we live in a universe dominated by matter. Physicists believe there must be a tiny, fundamental difference between matter and antimatter, a glitch in the symmetry, that allowed matter to prevail. Finding this difference is the key to understanding the origins of the cosmos. From CERN to the rest of Europe, while CERN is the world's premier site for producing antimatter, its massive machinery creates magnetic fluctuations and noise that can interfere with ultra-sensitive experiments. By proving that antimatter can be safely transported, scientists can now move these particles to quieter laboratories across Europe. For example, researchers could transport antiprotons to the Heinrich Heine University Dusseldorf in Germany, away from the electromagnetic interference of CERN's particle accelerators. Scientists can perform much more precise measurements to hunt for the subtle discrepancies that could rewrite our understanding of physics. Conclusion: by successfully moving antimatter by road, physicists have unlocked the ability to conduct high-precision research in specialized environments worldwide, bringing humanity one step closer to explaining why the universe is made of matter rather than nothingness.